So it's a real pleasure to be here today to tell you about our experience in designing, building, and running an introductory massive open online course on functional programming which was built around the OCaml programming language. I mean, running a MOOC is not an easy undertaking. So before starting doing the real work, we spent quite a bit of time in deciding what we wanted to achieve and what our approach should be. So let me give you the actual result of the long debate that were taking place before we actually started doing the work. We focused on having a single goal which is both humble and ambitious. The humble part is we only focused on the three key notions that you find in the programming language of the ML family. So of course functional programming, but also static typing, type inference, and algebraic data types. This is the humble part, no 3D things around that. But then the ambitious part was we really wanted to make sure that whomever passed the course and get to the end of the course really mastered this notion and could show their proficiency by writing significant pieces of code of a reasonable complexity. I mean, satisfying, and all this in just 7 weeks. Satisfying this last implication is very easy. You just make the course so complicated that nobody completes the course. So the implication, I complete, hence I know, is backwardsly satisfied. So to avoid this kind of trick, trap, we added an extra constraint to the system, which is we wanted to keep the learners as long as possible inside the course. How do you do this? I mean, our approach was to find the right balance between theory and practice. As you see in the title of the slide, is a kind of a spoiler. Practice was very, very, very important. So for the course material, we basically reused material that was well proven in years and years of teaching in the classroom, but we had to fully redesign it to fit in the MOOC standard. That means very, very small capsule, 3, 5, 6 minutes, depending on the concept, one capsule. And this was complemented by a really, really interesting exercise environment that you will see in a few minutes, which was key for the course approach because we wanted it to be really hands-on. In these 6 hours you had 6 hours of videos, and with the 6 hours of videos in 7 weeks, you had almost 50 exercises with automatic grading, and 2 full-blown projects which actually required significant commitment from the learners. Our own solution, the teacher solution, add up to some 1,500 lines of code, and as you can imagine, for the learners it was much more than that. So since we put so much emphasis on the exercises, we made a significant decision, pedagogical decision. No deadlines on turning in homeworks and doing the exercises, and no limitation on how many times you can submit your exercise to get a grading. Okay, seems like enabling cheating, right? I mean, if you do this in a classroom, but actually it worked very well, and not only helped people not to be limited by time, but it turned out, this was unexpected, that most of the students made a point of honor of getting 100% on all the exercises, and so they kept resubmitting even if they had very good grades. So these are the objectives and the approach. Let's have a look at what was actually achieved. The learners, well, in 2 rounds of the MOOC, we have over 7,000 people from over 120 countries registered for the course. That's a lot. But as always happens in MOOC, when you get to week 1, most of the people have gone, evaporated, but not so many. I mean, so a good third was still there on the first week. Then, of course, you had any kind of people attending, from 9 to 99 years old. I mean, unless there are bugs in the platform, so when you choose your birth date. And the remarkable fact for a MOOC like this is that we had just a large number of real students. I mean, people who were actually in bachelor or master's or PhD, and not typically, perhaps very often, professionals who try to learn new skills. What about learner fidelity? Well, actually, we achieved our goal. After week 2, I mean, the evaporation just disappeared, and we stuck with 600 people who actually wanted to be there and stayed there to the end of the course. And well, how difficult was it? We asked people who completed the course with an extensive questionnaire, And it turned out that the vast majority of the people found the course just right and spent more or less 4 hours per week working on it, which is kind of a lot for a monk. And also, independently of the level of education, most of the people found the course enjoyable. I mean, it was not a matter of how much you knew before coming into the course. Well, we really believe that the reason of this satisfaction lies in the remarkable platform which was set up for doing exercises. So I think this is a moment for you to see what this looks like, and I pass control to Benjamin.
Thank you. So is my mic working? Yes, it seems so. So actually we asked the student this question, what the components that you like the more within this MOOC, and what made you stick until the end of the course, and all of them mostly answered the exercise platform. So how did we achieve that? So first, we wanted to attract them to trap them, let's say, into the first exercise. So to do that, we really wanted to relieve them from all the boring stuff. When I say all the boring stuff, I mean mostly what you have to do when you want to start your first programming exercise, which is selecting your preferred text editor, or maybe we were targeting beginner students, so actually choosing your text editor, installing the environment, etc., etc. So, well, based on past experiments that we did, we decided to go fully JavaScript style and do everything inside the browser. All right, so basically the student would just finish the video from a specific part of the course, and then they would click on a link, and voila, they are in the IDE and they can complete the exercises. Okay. After that, we wanted them to keep focused on the exercise and stick with us until the end of the course. So we added this automatic grading system, which I will demo just a bit later. And we also gave them all the test cases. So the idea was, of course, to make them learn that tests are good and you have to write them. But that's a beginner course, so we'll write the test for you this time. So yes, that you learn what are good tests and how they are good for. Okay, so I will give you a short demo on the workflow from the student point of view. So if some of you logged into the OCaml MOOC, it's a revamped version of the MOOC with a more polished interface, but you will recognize all the components that the students see. So of course, when you click on an exercise, the first thing that you see is the text, or the English prose with the questions that you have to answer. Here it's a small exercise on binary trees in which we will try to complete the first assignment, which is compute the height of a binary tree. In some exercises, well, in most exercises, we provide some predefined types for the student to use. So it's in a prelude that is given to the student. And of course, it's a prelude because it's preloaded inside, for instance, the top level. So the student can do their own small test inside an OCaml top level that has been a little bit enhanced to be more good looking and display better warnings, this kind of stuff. But the main interface that the students will see when doing their 4 to 8 hours in average of work per week is the text editor. So it's a full-fledged OCaml text editor, usually filled with a template. So in this case, it's just a boilerplate template with placeholders, mostly there so that the student will not get frustrated by writing a typo in the function name, things like that. But we had some more advanced use, like filling this template with a buggy code and actually ask the student to fix the code or exhibit a bug, for instance. So let's write this height function as if I were a beginner OCaml student. Here you see the automatic indentation, so that the student learns the indentation, but they don't have to actually write indentation by themselves. So I believe that the height of the empty tree would be 0, and I then match the other code, which is a node with a left component, the value, a right component, and that would be the maximum of the height between the left component and the height between the right components, something like that. I'm a beginner, so I'm really bad at OCaml, and actually I get a syntax error. Okay, so I didn't write the function or the match clause. We'll use a match clause. Match t with. This time it should pass right and type check. So it type check. So now I will actually grade my code. So my computer is brand new and it's a fast machine, but most students use older machine or at the university shared machines. And anyway, the exercise is quite small, but we have actual problems inside it. So we added this animation and progressive grading so that you get a feeling of what the grader is actually doing. So I'm really bad at OCaml, it seems. But at least it passed and typed after the few errors. And it seems that I'm always returning 0, and it's right for the MT3, but I get only 1 point. Okay, so I believe that I forgot to add 1 to each level of the tree. Still type checking. Let's grade it once again. Every time you get a different animated camel. And I'm still quite bad at OCaml. And it looks like, so all the test cases are displayed, they are randomly selected, partially. You can see that some of the test cases are actually fixed. And it seems that it only works on symmetrical examples, so that wasn't actually not a scripted error. And let's grade it once again. And finally, I get my 100 points for the first exercise. And as you can see, the interface has folded this exercise for me and unfolded the report to the first error. So yeah, you got a grasp of what was the workflow of the student and how they have been trapped into this game of solving OCaml exercises in a funny web environment. So that was for the student point of view. Let's have a little look, quick look, as quick as possible, to our point of view, so the authors of the exercises. So we didn't have a lot of time, actually, to implement these exercises, like 2 months, something like that, not much more. And at first, we started to a humble environment, and we added features incrementally. And we made some design choices that were arguable, and that in the end ended up to be a really great choice, to our knowledge at least. One of the choices that we did is, well, usually automatic graders are language agnostic, very generic, and etc. We don't have time to write graders with this system because it's always hard to debug, etc. Instead, we will tightly couple our system to OCaml. So of course, it's a weakness. It's not portable directly. You can port the approach, but not the system itself. But it was easier for us at the moment, and it ended up being the right choice. So that will be the only technical explanation of the system. You have all the details in the paper. So everything is in OCaml. In particular, the graders are in OCaml, and how we run tests is very simple. We launch an OCaml compiler in the browser. We launch an OCaml top-level session. And in this session, we first run the prelude, then we run the student's code. We check that the student code matches some assumption that we do in the grader. Mostly, we introduce typed holes in the grader code. And if everything goes right, we run the grader right after the student's code. So the grader is type-checked, all right? The very specific places in which the grader will import student code are marked as with specific typed annotation. And the grader is actually able to manipulate values from student code right inside its own runtime environment. All right. So basically, then we just had to reuse or build our own combinator library because we are just testing OCaml function and OCaml values. Since we don't really make a difference between students' code and grader code. Again, I'm going really quick, so I hope it was clear enough. Otherwise, all the details are in the paper. So this approach has had a lot of advantages. We actually didn't find a case where we weren't able to implement the level of probing of student code and student side that we wanted. We are targeting beginners, so it's really important to test simple stuff regarding the syntax, for instance. we want to ask students, please write this function using the function keyword or using the match keyword, things like that. Since we are in the top level environment and we have full access to the compiler infrastructure, we can just intercept the compilation steps and introspect the AST from student code. Really trivial. We are targeting beginners and we are trying to make them learn the functional way of programming. So sometimes we wanted to ask them something about variable scoping, which is not clear when you come from an imperative world, for instance. So please use only local definition inside this global definition, or please use only global definition, or please use only variable of a given type, these kind of things. And as we have access to the typed AST and to the typing environment, it's easy to do once again. Another thing that we did is that we have been able to do is not because the grader has access to the code, but because it has access to the evaluation and to the values that come from the student's code, which is taking a function from the student, calling it, observing its return value, and also because OCaml is not purely functional, observing its side effects. So we have been able to grade all the imperative aspects of OCaml just by observing the effect of a function on the reference that we pass to it, for instance. We have been able, using this trick, to implement some more advanced features, such as instrumenting the operators from the standard library in order to count the number of operations and to give an evaluation of the algorithmical complexity of functions to the student. And in the end, not because of this tightly coupling, but because of OCaml's advanced feature in the type system, we have even been able to grade more engineering aspects of the exercises by using the module system of OCaml. So loading the top-level structure of the student's code and then loading it as a first-class module in OCaml and then testing it as any other value, as we can do that in the language. So that was a lot of work done in not that much time. It's like 15,000 lines of code on our side. The important lines that you want to remember are the 1,500 lines of code in our own idiomatic and short solutions, and the 4,700 lines of code in the test. So a ratio of about 3. For having used other automatic grading systems in the past, we were quite proud of this ratio. And not only was this ratio good, but the static typing of graders in advance gave us a lot of confidence in our system. And instead of writing the few exercises that we prepared, we actually wrote a lot of exercises, much more than we wanted to write. Yeah, so I think this decision of tightly coupling with OCaml was the right one. So enough with the safe praise. I try to be as quick as possible. We have a few critiques to do on this system. The first one that we got mostly from other OCaml developers is that, well, we removed all the boring stuff from the student learning time, so it means that they don't learn the boring stuff, and if you want to be an actual OCaml programmer, you have to learn that. So yeah, that was a decision on our part, an arguable decision, of course. The main criticism that we had from students, and which is understandable, is the lack of human feedback in the system. I'm not sure we all agree on that, but my idea is that, well, if we want to have human feedback, we have to have human in the loop. That's what MOOCs are for, having automatic grading and also humans assisting students online. And if we build this autonomous platform, we will add a social or human component to it to have this. So, a few words of conclusion. We trained 600 OCaml programmers that wrote about 2,000 offline because they all got to about 100% success rate. So they actually all write that. With a small project, there was a puzzle game solver and a Markov chain text generator, which each project is a few hundred lines of code, so a non-trivial small project for OCaml beginner. And yeah, we are really proud of that. Thank you.